All right, so we are going to review activities 12 and 13 here. So just looking at the concepts that you need to make sure that you know. First, you need to make sure that you know how to write expressions and functions based on given information. You need to make sure that you can graph a quadratic function. That's in standard form. You need to make sure that you can identify the key features of a parabola. And you need to make sure that you can find those by hand and with your graphing calculator. You want to make sure that you can graph quadratic inequalities. You need to make sure that you can solve a system of one quad and one linear, both algebraically and graphically. And I think, and you need to make sure you can use the discriminant to determine number and type of both solutions and X-intercepts. All right, so these are the topics that we're going to be covering. Again, I'm just going to go through some of the problems in your review. Remember, this covers just activity 12 and 13. So if you're watching this before the embedded assessment, this is going to cover everything. If you're watching this before the Quest Part 2, remember that this is only half of it. Quest Part 2 also covers activities 10 and 11. So you want to make sure that if you think you're rusty on those kinds of problems, that you watch that review video as well. So as we are looking at these problems, making sure that you can write expressions and functions based on the given info, that's what you're doing in the first couple of questions here. So it gives you in number 1 a table that you're supposed to fill out based on the information that they give you there. And if I can find mine, so it says the cost of tickets to a whale watching tour depends on the number of people in the group. I bet I can bring it up on the screen here. That would be better. There we go. Depends on the number of people in a group. For each additional person, the cost per ticket decreases by $1. For a group with only 2 people, the cost per ticket is $44. Use this information for items 1 through 7. So, first thing that it wanted us to do in number 1 is fill out the chart. So that one's pretty easy because the cost per ticket goes down. So a group with 2 people, they gave us that information. When this was 2, then it said the cost per ticket is $44. Then it says it goes down by $1 for each additional person. So 3 then gives us 43, 4 gives us 42, and 5 gives us 41. So that's pretty standard. I think most people can do that. Then use the data in the table to write an expression that models the cost per ticket in terms of X, the number of people in a group. So even though you're writing an expression here, this expression is linear. So you need to make sure that you are writing it as such. So there's a couple of different ways that you can do this. The slope, I think, is pretty easy to see because you're decreasing by 1 on the y for every 1 you go up on the x. Remember that slope is rate of change. It's the change in y, these little triangles mean change in, over change in x. So if you look at just these two sets of data, the y is changing by going down by 1, the x is changing by going up by 1, so positive and negative. The slope is -1. I think that most of you can see that just by looking at the pattern. The pattern is to go down by 1 for every whole number change. Now, if you couldn't see that, remember that the formula for slope is y2 minus y1 over x2 minus x1. So if you didn't know that, then pick 2 points, y2 minus y1, so 43 minus 44 over 3 minus 2. So again, you're going to get the same thing regardless of which way you do that. So we know that the slope is -1. Now we need the y-intercept. So a couple different ways that you could have done this. You could have used point slope form and kind of written it that way. So you could have done y minus y1 equals m times x minus x1 by plugging in the slope that we know, which is -1, and picking a point. So it doesn't matter which. Let's say that I just picked the first one. So x minus the first x coordinate is 2. Y minus the y coordinate there, which is 44. So that gives me -x plus 2, y minus 44. And then if we add the 44, we see that we get -x plus 46. Because when I add the 44 here, they cancel. When I add it here, that gives you 46. Now again, it only asked for an expression, so it doesn't need the y equals part. So you could have done it this way, and this is a perfectly acceptable answer. Probably a lot of you just continued the pattern to find what it would be when x is 0, because remember that a y-intercept is when x is having a value of 0. So if I just continued the pattern backwards and made 145 and 046, then I could automatically see that that's my intercept. I wrote mine 46 minus x because of the way I calculated it, but -x plus 46 is the same thing. So those are perfectly fine. So then that takes care of writing expressions based on given info. Writing a function, that's what you're doing in number 3, because it asks in number 3, let's take a look at it here. Here it is. Write a quadratic function in standard form that models t of x, the total cost for tickets for a group with x people. So the total cost is going to be cost times number of people. So it says the number of people is x, so t of x equals number of people, which is x, times the cost per person, which is this guy. So -x plus 46. So it did say standard form, so that means you need to distribute -x squared plus 46x. And so that's how I got my answer, t of x equals -x squared plus 46x. All right, so you can use your graphing calculator to graph that one. I'm not going to go over those specifics in this case, because a lot of what you have to do there we cover with some of the other questions that we're going to look at. So if you still have questions on, like, say, number 6 or something like that, if you didn't know how to do it in your graphing calculator, we will get to some examples that will help you with that here in a moment. So All right, so the next one I want to look at is, excuse me, number 15, because this is one of the ones where you have to find the X-intercepts and the Y-intercepts. So you're given f of x equals 2x squared plus 13x plus 15. This is meant to be done by hand here because this is not a real life situation and we're not graphing it. So to find the X-intercepts, remember that you put 0 in for y and then you solve. So this is a quadratic equation that I need to solve. I always try to see if it's factorable first because factoring is the easiest way to solve if it is factorable. So I look at this, there is no GCF, so then I look to see could there be numbers that multiply to 2 times 15, so multiply to 30 and add to 13, because that's what I'm going to need to happen in order for this to be factorable. So yep, really quickly I can find 10 and 3, multiply to 30 and add to 13, so I know this is going to be factorable. So I usually factor using guess and check. So I know 2 is prime, so I know it's 2x and 1x. And so then 15's factors that are closest together are 3 and 5, so I'll try those first. First's 2x times x is 2x squared. Outside's 2x times 5 is 10x. Inside's 3x, that is the 10 and the 3 that I want. Last's plus 15, so this is a correct factorization, which means that to find the x-intercepts, I just need to set each of these equal to 0. So here I'm going to subtract 3 first, 2x equals -3, and then divide by 2. Remember, decimals are not okay here. We're doing this by hand, so it needs to be in fraction form. So -3 over 2 is going to be your answer there. And then here, that's an easy one, just subtract the 5. So x equals -3/2 and x equals -5. So that means when I list my x-intercepts, remember that they are ordered pairs. So these are my answers for my x-intercepts. Then it also asks me to find the y-intercepts. So y-intercept I find by plugging in 0 for x. So I go back up here and I plug in 0 where x was. So 2 times 0 squared plus 13 times 0 plus 15. So for the y-intercept, the first one, this is 0 times 2, which is 0, plus 13 times 0, which is 0, plus 15. So my y-intercept is going to be the point 0, 15, because again, it's an ordered pair, so make sure you list it as such. So those are your answers for 15 and how we got them. Again, if you had trouble on number 5, or not 5, number 6 in this, what I'm going to do in the next problem helps you with that one as well. So the next one I'm going to do is number 17. And that one you're starting out with f of x equals 2x squared minus 12x plus 13. And this time it asks you to find all the key features of the parabola. So here in 15 it only asked me to find a couple. So here I'm going to be finding the features of a parabola by hand first. So the key features I need to find: vertex, y-intercept, x-intercept, axis of symmetry, and then determining if it has a minimum or maximum and what that min or max is. So I'm going to do the vertex first. Vertex, you find the x-coordinate by doing opposite of b over 2a. This is what you have to do in number 6. Same thing that I'm doing for the vertex here. So opposite of b, my b is -12, so opposite of b would be +12 over 2 times a, which is 2. So that's 12 over 4, which is 3. So the x-coordinate of my vertex is 3. Remember that to find the y-coordinate, you have to plug in the x-coordinate. So I'm doing 2 times 3 squared minus 12 times 3 plus 13. So order of operations, exponents first, 3 squared is 9, then multiplication, 2 times 9 is 18, negative 12 times 3 is negative 36, and then I've got a plus 13. So 18 take away 36 is negative 18, plus 13 gives me negative 5. So that means that my vertex is at 3, negative 5. So there's how we find the vertex by hand. X-intercepts, we already talked about how to find by hand up here, same with Y-intercept, but it might look a little different depending on the problem. So the Y-intercept, I plug in 0 for X. So 2 times 0 squared minus 12 times 0 plus 13. So 0, 0, 13. So the Y-intercept is 0, 13. X-intercepts, you have to plug in 0 for Y. So 0 equals 2x squared minus 12x plus 13. And now I need to solve for x. Again, I usually try to factor first. Here, there is no GCF, so I'd be looking to see if there's something that multiplies to 26 and adds to negative 12. So factors of 26, I know they have to be negatives to add to give you a negative. So negative 1, negative 26, that doesn't work. Negative 2, negative 13, that doesn't work. 26 is not divisible by 3. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6, not by 7, not by 8, not by 9, not by 10, not by 11, and not by 12. So we found all the factors, neither of them worked, which means this is not factorable. So again, you have a choice here of how you want to solve this. You can solve this by completing the square, or you can solve it using the quadratic formula. When b is even, I almost always complete the square. Again, that's up to you. So if I want to complete the square, I'm going to move these two over to the left and this guy to the right. Notice that I changed the sign on the 13 because if I want to move it, I have to do so by subtracting. So the 13 is negative, these two are positive, how I did that. So now to complete the square, first I factor out the a, so that gives me x squared minus 6x. Then I add my blanks. Fill in the blank on the left side with b divided by 2 squared. So b is negative 6. I divide that by 2, which is negative 3, and then I square it to get 9. On the right side, I multiply the a times the left blank, so that gives me 18. Once my blanks are filled in, then I factor the parenthesis on the left side as a PST, so square root of the first term, which is x, sine of the middle term, which is minus, square root of the third term, which is 3. So x minus 3 squared. And then add the terms on the right side, which gives me positive 5. So now I can solve first by dividing by 2. Those cancel, so I've got x minus 3 squared equals 5 over 2, and then taking the square root on both sides. So when I take the square root there, I've got x minus 3 equals, and then I've got plus or minus, square root of 5 over the square root of 2. I can't leave it like that. No radicals in the denominator. So I need to rationalize by multiplying top and bottom by radical 2. So this is going to change to plus and minus radical 10 over a plane 2 once it's rationalized. So I can kind of cross this guy out. This is what I have now on the right side. So then final step is to add the 3. It is not like terms with this. So I've got 3 plus or minus radical 10 over 2. Now, if you solved this by using the quadratic formula, it's possible that you might have your answer listed as 6 plus or minus radical 10 over 2, which is fine. You don't need to change it if you did that. So remember, these are X-intercepts, so I leave them in intercept form, meaning they need to be an ordered pair. So I'm just going to put plus or minus in there. If you list them separately, that's totally fine. That's up to you. So these are your X-intercepts. 3 plus radical 10 over 2 and 3 minus radical 10 over 2. All right, so those are good to go on X-intercepts. Then it also asked me for the axis of symmetry. Don't worry, we've done all of the hard work. The rest of it should just be listing some stuff. So I've got the Y-intercept, I've got the X-intercept. The axis of symmetry, which I usually abbreviate AOS. Remember that it's written X equals opposite of B over 2A, or X equals the X coordinate of the vertex. So in this case, the X coordinate of the vertex, because I already did opposite of B over 2A up here, and it was 3. So the axis of symmetry is X equals 3, because that's the vertical line that goes through the vertex. So then, final thing it asked is, does this graph have a minimum or a maximum, and what is it? Well, you know if it has a min or a max by which direction it opens. Since A is positive, this opens up, which means in general its shape looks like this. So that means it's going to have a minimum. The max or min is always the y coordinate of the vertex. So in this case, it has a min at -5. Again, all of these, this is on a non-graphing calculator part. So you have to make sure that you know how to find those, not using the second trace menu in your graphing calculator. You have to be able to do this by hand. All right, so going to look at 20 and 21 here. So it says the function h of t equals -5t squared plus 15t plus 1 models the height in meters of an arrow t seconds after it's shot. Use this information for 20 and 21. So 20 asks, based on the model, when will the arrow have a height of 10 meters? Round times to the nearest tenth of a second. Explain how you determined your answer. This is a real-life situation. You should be using your graphing calculator for this. We don't have time to always solve by hand. So this one you should be doing on your graphing calculator. Remember, you have to use X. You can't use T's in your Y equals. But I went ahead and typed in the equation using X instead of T, and I adjusted my window to something that I thought might be appropriate, and I pressed graph. So I can see here the entire parabola, so it looks like I'm okay for my window. But it says, based on the model, when will the arrow have a height of 10 meters? So in order to find that, because height is a y coordinate, I could look at the table to see, but I don't see anything. 10 meters isn't listed here. I've got 11, so I've got something that's close, so I know it's maybe somewhere between 1 and 2. But I need to find the exact value, so that means I'm going to need to graph y equals 10. So all this stuff we did before in activity 7, graph that, and then I'm going to find the intersection points. So second trace, choice 5 for intercept. And it says first curve. Remember, I want my blinky to be close to one of the intersections, so I'm moving it till it's close to one of them. First curve just means, is this the first equation up at the top? So I press enter to tell it yes. Now look at switch to the other one. Yes, that's the second one. And yes, a third time I want you to guess. So it says 2.17 there. So when I look at that, it said to round to the nearest tenth. So that means that on this one, for number 20, one of the values is going to be after 2.2 seconds. Because It's rounded to the nearest tenth. That's what that intersection point gives me. Now, that's not my only solution, because if I look here, there's another intersection point as well. So I do second trace intersect again. Remember, you've got to move the cursor over. If you don't move it close, it's still going to find the other one. So first curve, yes, that's my first equation. Yes, this is my second equation. Yes, I want you to guess. And then it tells me that that intersection, if we're rounding to the nearest tenth again, is at 0.8, because 0.82 does not round up. So after 2.2 seconds and after 0.8 seconds are the two answers there for number 20. For explain how you got your answer, just say you graphed the equation in Y1 and 10 in your Y2 and found the intersection. So second trace intercept. Number 21 wants you to ask and answer, does the arrow reach a height of 12 meters? Justify your answer both graphically and algebraically. There's a question very similar to this on the embedded assessment, and we've done a lot like this in class. If I change in my y equals screen that 10 to a 12, I should be able to see graphically whether or not it reaches that. So if you look here, the blue does go just above the red line, which means yes, it is going to reach a height of 12. So graphically, we can say yes, there are two visible intersection points. I think on the answers I listed them for you. It doesn't ask you for that information, so you don't have to find them. You just have to prove that there are some. So graphically, you just look at it and say, yes, there are two visible intersection points. Now, algebraically, that requires that we do a little bit of work. So my suggestion algebraically, because what this means is you're asking, are there solutions when I plug 12 in for y? So 12 equals negative 5 t squared plus 15t plus 1. So this is just asking you, are there solutions to this quadratic? So again, you've got a couple choices here. I would probably get it equal to 0. So 0 equals negative 5t squared plus 15t minus 11, and then find the discriminant. I think that that's the fastest way to do it. It's not the only way to do it, but it has to be algebraic. So the discriminant, remember, is b squared, so 15 squared, minus 4 times a times c. So if we look at this, 15 squared is 225. I've got 3 negatives, which means this is going to be a minus. 4 times 5 is 20. And so then I take that positive 20 times the negative 11, which gives me a negative 220. So it was a minus there, so minus 220, which gives me a discriminant of 5. So again, I'm not actually asked for the solutions here, so you don't have to solve it. You can. That is one way to answer the question. However, this is a little bit faster to just say yes when y is 12, the discriminant is positive, which means there are two real solutions. Now again, you don't have to do it this way. You could actually put the 12 in and solve the whole thing for t and say, yes, I got answers that would make sense in a real life situation. So that would be another way to approach that particular problem. All right, so we have touched on the discriminant already, which is what a couple of the other questions ask you to find. Remember that in lessons 12.4 and 12.5, we did those in the graphing calculator. So on number 25, when it asks you to find the x-intercepts, remember you're allowed to do those ones in the calculator because that's what we did when we did lesson 12.4 and 12.5 to begin with. But if we look back here at what we did in 12.4, if you're having any trouble with the questions about the discriminant, so 25 through 28, I believe, are all about the discriminant. You need to go back to lesson 12.4 and look at this chart because right here it tells you everything you need to know about that discriminant. So discriminant is b squared minus 4ac. If it's positive and not a perfect square, then that means the roots are irrational, so two real irrational roots. If it is a perfect square, then the roots are rational, so two real rationals. So if the discriminant is positive, that always means that there are two real solutions and two x-intercepts. If the discriminant is equal to 0, that means one real rational solution, which means on the graph there would be just one x-intercept. And then finally, if the discriminant is negative, that means you're going to have two complex conjugate solutions, which means that there are no x-intercepts. So this graph is actually wrong on the online version. I think, I can't remember if they corrected that in your book or not for this year, but we had said it in class that means it's not going to touch. So this picture is not what it should look like. It should be a parabola that's completely above the axis or completely below the axis. I believe that that is changed. It's changed in my printed version. I don't know why the online version isn't changed, but the picture in your book should be accurate on page 204. So if you're having trouble with discriminant issues, that's where you need to look for that. So let's take a look at where we are as far as covering all the things. We used the discriminant. We have identified key features by hand. So now we just need to look at graphing a quadratic in standard form. So we could do that, remember, with the by hand. So if I were asked to graph 17, I would plot the vertex, plot the y-intercept, plot both x-intercepts, and then connect the dots. So that's how we can do that by hand. So we can check that off by hand. Now we're going to look at how we can do that using the graphing calculator. So I'm going to actually combine that with the quadratic inequalities. So we are going to look here at number 29. Which gives you y is less than x squared plus 7x plus 10. Now, if this were an equals, the only thing that's going to change is the symbol that we're putting into our calculator. So I need to go back to my y equals screen. I need to delete out the stuff that I don't need. I'm going to type in my x squared plus 7x plus 10. And I'm going to change my symbol. Remember, if you're running the app, you can change it when you're over top of the equal sign. So if you have the app on your calculator, when you're over the equal sign, if you run the app, you can press alpha and then whichever button corresponds to the symbol that you want. If you don't have that app, then you need to move to the left of Y1 and press enter. And then as I taught you in class, again, yours might not look just like mine, but you need to change yours. If you've got one that actually gives you the less than symbol, that's great. Choose the less than symbol. If not, you're looking for this because that's the lower half plane shaded. And so that's okay. So I'm going to zoom 6 since I had adjusted my window before. And it shows me a very lovely graph. So if you're graphing using your graphing calculator and it weren't an inequality, then of course you would just have the parabola without the shading. So being able to actually graph this inequality, remember that you need to record the vertex and the X-intercepts, if there are X-intercepts, and you need to plot exact points. Remember that if you need more, you can always look at second graph because it gives you a whole bunch of points to plot. So I'm going to find both of these X-intercepts as well as the vertex. So X-intercepts, I do second trace, choice 2. So I need to move my blinky guy left bound. So I'm going to find this X-intercept first. So left bound here would be below because that gives me a value to the left. So I press enter. I go right bound, press enter again, and press enter to tell it to guess. It tells me that that X-intercept is exactly at -2. So where it looks, it actually is. So I would record, because remember your work here is to actually list them. So I list one of my X-intercepts at -2, 0. Then I need to go and find the other one. So I do the same thing, second trace, choice 2, to find the zeros. So left bound this time would be kind of above, so I press enter. Then right bound, notice how it puts in this line to the left, then right bound enter, puts in the line to the right, my 0 should be between it, then tell it to guess. This one is at an exact coordinate 2, that's at -5, 0. So I've got my X-intercepts. Now I need to find my vertex, so second trace again. Since this one opens up, the vertex is at a minimum. Remember that if it opens down, you would be using choice 4, maximum. So this time I'm going to use choice 3. Minimum, so left bound this time means left of the vertex. So I'm just to the left of the vertex. Then I move just to the right of the vertex. And then I tell it to guess. Minimum 3.5, -2.25. So vertex is at, I already forgot what the coordinates were, -3.5, -2.25. And so if you were asked to graph that inequality, that's the work that you would do. This is all you would write down, and then you would actually plot it. So you would take those X-intercepts, one at -2, one at -5, and plot those. Then you would plot the vertex, so -3.5, -2.25, so it would be right here. Now, this is a plain less than. So some of your calculators, depending on which symbol, if you were able to choose the symbol, you might be able to see that it's supposed to be dashed. Some of them don't have that capability. Mine actually, the on-screen one, doesn't have that capability. So you have to know, look at the symbol. If it's a plain less than or a plain greater than, it should be dashed. If it is having the equals underneath, then it should be solid. And obviously you could see from the graph that the shading is below since it's a less than, so then you would just draw in your shading to get that. So that would be your answer there on 29. All right. We're getting there. So now we have taken care of graphing quadratic inequalities and how you would identify the key features in your calculator, because we found X-intercepts and the vertex there. And so we graphed something that was in standard form as well. So now the only thing left is solving a system of one quadratic and one linear, graphically and algebraically. So solving graphically, that was in section 13.1. So any of the problems that were from lesson 13.1, you could solve with your graphing calculator. 13.2, you needed to do by hand. So number 6, number 2, all of those ones you could have used the graphing calculator for. 10 and 11, it actually didn't even ask you to solve. It just asked how many solutions there were. So on those ones, you just graph it and look and see how many intersection points there were. So again, I'm not going to go through that function because we already did an intersection on this video. So all you're doing is graphing the parabola in your Y1, the line in your Y2 or vice versa, and then using second trace intersect for those. So what I want to go over is the ones from 13.2, one where you have to solve it algebraically. So we are going to look at let's do number 18, where you had y equals -3 times x minus 4 squared plus 2, and y equals 6x minus 31. So remember, step 1 is to set them equal to each other and solve for x. So I'm going to do -3 times x minus 4 squared plus 2 equals 6x minus 31. So this one, in order to solve for x, because there's a linear term out here, I need to FOIL and distribute. So x minus 4 squared means x minus 4 times x minus 4. So if you need to write it out to FOIL it, that's fine. First's x squared, outside's -4x, inside's also -4x, and last's a plus 16. So when I combine these like terms in the middle, I get -8x. So in my first step, I FOIL that out. I haven't done anything else yet. Now I'm going to distribute. So that gives me -3x squared plus 24x minus 48. And then don't forget your plus 2 that was on the end, equals 6x minus 31. In order to solve for x, I need to get it all equal to 0. I prefer that my quadratic term be positive, so I'm actually going to move everything over to the other side. So I'm going to add 3x squared. It doesn't have a like term, so I'll put it by itself over here. Those cancel. I'm going to subtract 24x minus 24x underneath its like term. These two together are a -46, so when I'm actually going to move it, I would be adding. So plus 46. So when I combine the like terms, I know I've got 0 over here. Here I've got 3x squared. 6x minus 24x is -18x. And 31 plus 46 is positive 15. So I set them equal to each other. Now I need to solve for x. Again, I usually try to factor first. If you just love completing the square or doing the quadratic formula, you can choose that as well. This has a GCF, so I take that out. And then, oh, lucky me, it is an easy type of factoring because now my leading coefficient is 1. So all I'm doing is saying what multiplies to 5 and adds to -6. So that's easy. -5, -1, add to -6. So that means this is x minus 1 times x minus 5. So then when I set each parenthesis equal to 0, that means that x equals 1 and x equals 5. All right, so step 1 is done, and that's the hardest step. That's where most of the work is. Step 2 is to find the y-coordinates by plugging in these values for x. So remember, you always want to plug into the linear one. Don't try to plug into the quadratic. That's too hard. So I'm going to plug in x values right here. So y equals 6 times 1 minus 31. So that gives me 6 minus 31, which gives me -25. Over here, when x is 5, 6 times 5 minus 31. This is 30. 30 minus 31 is -1. Step 3 then is to list them as ordered pairs. So I've got 1 with -25 and 5 with -1 as my two solutions. All right, all of the ones following that kind of follow the same pattern. Again, if you look at, I'm just going to give you a little help on the setup for the last couple problems. Number 25, it asks you, it says, for a piece of non-glare glass, the charge is equal to the length of the longest side in inches multiplied by the rate of 75 cents per inch. So it really tells you how to set that up in 25, but wants you to write a function. It says the charge, which is f of x, is equal to the length of the longest side in inches, which is what we don't know, that's x, because it says for a piece whose longest side measures x inches, so x times, it says multiplied by 0.75, so that is how I got 0.75x, because that's what you get when you multiply them. On 26, you're just taking the table and you're running quadratic regression. I'm not going to run through those steps again. If you want to see it again, you can look at the activity 10 and 11 review video because I did it in that one. And so then in 27, you've got a system that you can then solve there. All right, that should cover everything that you need for the embedded assessment and the problems that will be on the quest from these two activities.